In this video we look at the FP1 work about differentiation from first principles. This work is a natural continuation of what you will have already seen in C1, and the major difference between this and C1 work is simply that the functions that are going to be considered will tend to be a little bit more complicated. In particular, the function to be differentiated may well be a fraction. It's important to get the key idea clear about differentiation from first principles. So in the diagram we've got the curve y equals f of x, which is the red curve. We've got a point P on the curve, and we have drawn in the tangent to the curve at the point P. We have a second point on the curve, which is the point Q, and then we have joined up the points P and Q with a straight line. And it's very easy to write down an expression for the gradient of the chord PQ. The gradient PQ is the y step between P and Q, which is f of a plus h minus f of a, divided by the x step between P and Q, which is just h. Now, the gradient of the tangent is f dash a, and f dash a is not quite the same thing as the gradient of PQ. Gradient of PQ will be quite a decent approximation to the tangent, to the gradient of the tangent, provided Q is close to P. And if we push the point Q closer and closer to P, the approximation will get better and better. So what we can say is that the value of f dash a is the limit as h tends to 0 of f of a plus h minus f of a divided by h. And it's quite important to note that there are two different notations commonly used in this work, and that some people use delta x instead of h in everything that follows. So let's see how we would handle a examination question on this topic. The first thing to do on a question like this is simply to define the function f of x. So in this case here we've got f of x must be 1 over 1 minus x. Now, second step is just to write down and then simplify the expression f of a plus h minus f of a. Well, f of a plus h is going to be 1 over 1 minus a plus h. F of a is going to be 1 over 1 minus a. In order to simplify this, the first thing we need to do is get rid of the brackets on the first fraction. So we've now got 1 over 1 minus a minus h, take away 1 over 1 minus a. We're subtracting two fractions, so the sensible thing is to move towards a common denominator. So the common denominator will be 1 minus a minus h times by 1 minus a. Now, with the first fraction, which was 1 over 1 minus a minus h, we've had to multiply the denominator by 1 minus a to move to the common denominator. So we must do the same to the top. So the top will now become 1 minus a. On the second fraction, the denominator was 1 minus a. We've had to multiply that by 1 minus a minus h to move to the common denominator, so we must do the same to the 1 on the top. So we've now got the two fractions having a common denominator, so we can perform the subtraction. So we've got 1 minus a, take away 1 minus a minus h, all over 1 minus a minus h times by 1 minus a. And if we look at the numerator of that fraction, we can see that the 1's cancel out and the a's will cancel out, so that we are just left with h over 1 minus a minus h times by 1 minus a. So we now want to move on to think about f of a plus h minus f of a, all divided by h. So f of a plus h minus f of a over h is the expression we've just got for f of a plus h minus f of a divided by h. Now it might be helpful to think of that as being a division sum. And if we then think that dividing by h is the same thing as multiplying by 1 over h, we have now got a fraction multiplication to do, and we can spot quickly that in fact we can cancel out the h on the numerator of the first fraction with the h on the denominator of the second fraction. So we're ending up with a final expression for f of a plus h minus f of a over h of 1 over 1 minus a minus h times by 1 minus a. And our final step now is simply to use the fact that the gradient f dash a is the limit as h tends to 0 of f of a plus h minus f of a over h. So we've got f dash a is the limit as h tends to 0 of 1 over 1 minus a minus h times by 1 minus a. Now as h tends to 0, nothing happens to the 1 at all, nothing happens to the bracket of 1 minus a, but the bracket which is 1 minus a minus h, as h tends to 0, is just going to get closer and closer to 1 minus a. So we've got f dash a is equal to 1 over 1 minus a times 1 minus a, which is of course 1 over 1 minus a squared. So we've got f dash a is 1 over 1 minus a squared, or equivalently we've got f dash x is 1 over 1 minus x squared. So we have differentiated the function from first principles. In terms of the mark scheme for this question, there were 2 marks for, first of all, considering f of a plus h minus f of a and starting the algebraic manipulation of that expression, and then 2 more marks for completing that simplification sensibly. The final 2 marks were for considering f of a plus h minus f of a divided by h and working out what happens as h tends to 0.